I'm now joined by Will Merredith, who is going to tell us all about chemical and environmental engineering. So, Will, why should someone consider studying chemical and environmental engineering? What's happening in this area that you're excited about?
We're really at the interface of science and engineering, and we are probably the most gender balanced of the engineering disciplines. And it's really about, if you like, engineering the future. The society has needs for fuels, for pharmaceuticals, for foods, and if we want to do that in a sustainable way, if we want to reduce our carbon emissions, we want to clean up our waterways, it's going to be chemical and environmental engineers who are going to be at the heart of that.
Brilliant, thank you. That sounds super interesting. Could you give me a short overview of the range of different courses that are available in your department?
Okay. It's quite confusing, but it's not actually that worrisome. We do 3 streams. We do straight chemical engineering, straight environmental engineering, and a kind of a 50-50 chemical with environmental engineering. All 3 streams are offered both as a 3-year BEng programme or a 4-year MEng with an integrated master's, and again, both come with the option of an industrial year. So in total, there are 12 different courses. However, the key things are that from an admissions perspective, they are all treated the same, okay? And the first year is common across all 3 streams.
Okay.
And so you can transfer at the end of year 1. There's total flexibility between the BEng and the MEng, and you can opt in or opt out of the industrial year as you move through. So you were very much treated as one cohort. Mm-hmm. All of the lab groups are mixed between the 3 streams. All of the design groups are mixed between the 3 streams. And many of the modules are core to the 3 streams. So you are very much treated as one group.
And if you change your mind, that's okay.
You can change, yeah.
Yeah, brilliant, thank you. So I'm guessing that this is quite a fast-moving area in science and technology. So how does the curriculum adapt to changing environments?
Okay, this is super important for us because our students tend to have to be very focused on their future career. And so we adapt this in many ways. Firstly, we're fully accredited by both the IChemE and the IOM3, who essentially their role is to dictate what a graduate professional engineer should have been taught. We have an industrial advisory board to advise us on our curriculums, but for us the most important way is via feedback from our students when they're on placement. As academics, we go to visit all of our students, and we always ask them whether they feel as if their courses has prepared them for the role they've gone into. And we also ask their line managers whether our students have the skills that they think they should have. And if we get any recurring themes being fed back to us, then we will address that. So recently we introduced coding, a lot more coding throughout the programmes. You know, we're not computer scientists. Coding is very much a tool, as AutoCAD is, as HYSYS is. And so we try to integrate that into multiple places within our modules, just to give our students the confidence when they go into that work environment that they'll be well prepared.
That's really great, and I'm hoping that's a reassuring thing to hear, that by the time they start in their careers, they are really well equipped for that environment. So thank you. So we have really great facilities on campus, and I wanted to ask how students access and benefit from research labs, workshops and collaborative spaces on the course. Okay,
so certainly from Chem-Eng is a practical subject. So we have some very large, some quite impressive labs. And obviously in year 1, these starts quite small scale and you're quite directed into what you're doing. But as you move through the programmes, things go to a pilot scale, to a much bigger scale. And the students are expected almost to design their way out of the problems they've been set. We have a great design focus in our teaching, and this is enabled by our design studios. These are open 24 hours a day. They are big collaborative workspaces. Historically, when we introduced a lot of design, the students would complain that there was nowhere for them to work together, and they were holding meetings in coffee shops or libraries. So we ripped out a load of our old teaching spaces, put in these design studios, big desks, big TVs, and for them to work around. And these spaces are very much the domain of our industrial design tutors, who are recruited from industry. They're academics, but they don't have the research background that we traditional academics do. They simply facilitate the teaching of our design, and they will stroll around these design studios looking over the shoulders of our undergraduates, raising a sceptical eyebrow and hopefully diverting them onto a more correct path.
Great. That sounds like such an innovative space for students to collaborate. Yeah, great. So you've touched on placements a bit already, but could you tell us a bit more about the kind of hands-on projects that students can get involved with and the placements during their time here?
Okay, our placements are a huge integral part of our courses. Last year, for example, we had 75 students on placements, and these will be at multinationals that you'll have heard of, smaller SMEs across a range of sectors: nuclear, food, water, energy, pharmaceuticals. And as I say, we go to visit them whilst they're on placement. And those roles, they're paid. They are generally, if you're on the MEng programme, you go in after year 3, so you're essentially a BEng graduate at that point. So, they're given a challenging professional role, and that will help them, obviously, whilst they're away. They come back with a lot more of a professional attitude, which is great to teach in their final year. But it's not just around the placements. We do have students who want to go straight through, and so we seek to facilitate that. They will apply for summer placements. We run a scheme doing research placements embedded within our research groups over the summer, if for students who might have an interest in going into academia. All of those are hugely beneficial in terms of getting the softer professional skills that our students will need in their careers.
Brilliant. And I feel like you've touched on this already, but is there anything else that you want to add about how the department prepares students for the job market?
Okay, so as I mentioned before, we have a very strong design focus. Now, all chemical engineering courses will teach design, but we do it from year 1. We get you into groups, not of your own choosing, and it starts off generally quite narrow in scope, something like water treatment. But over the second year and then into the third year, the projects become much larger, much more multifaceted. Again, last year it was designing a biofuel facility for our third years. This year it is hydrogen production. So again, it's very much hopefully the industries of the future. And it is that professionalism and those soft skills that we find are really valued, both when our students if they go into engineering, but also if they decide they want to go and work in alternative sectors. They're essentially hopefully come out as sort of mathematical, team-working, problem-solving individuals, which is valued just as much in finance, in project management, in management consultancy, as it is within traditional engineering sectors.
The world is their oyster.
Yeah.
Brilliant, thank you. So what advice would you give to a prospective student when they're applying for university?
Speaking also as a parent of a current second year and someone who's doing UCAS, it's very much to go to where you feel comfortable. If you can spend some time there, that's great. But from events like this, you can get across a sense of the community you'd be joining, the way of teaching. Certainly, if you apply to Nottingham, we would say don't worry too much about the chemistry and the physics. We'll teach you that during year 1. The maths, though, is core. But just to go somewhere that you think you will feel comfortable to spend 3, 4, 5 years. All of the different universities that teach chemical engineering will essentially teach the same things. They might teach it in slightly different ways. So the key is to try to find the one that you think will suit your personality.
Thanks, Will. Visit the website for anything else you'd like to know.